man on the left is Joe Montemarano, and that's Troy Grover on the right. They're laying up a nose cone in a fiberglass mold for their new underwing cargo pods. These aftermarket pods are designed to fit under the wing of the very popular home-built RV4 and RV6 kit planes. They allow owners to carry an extra 50 pounds of baggage without seriously affecting the balance or performance of these fast little airplanes. The pods are made of molded fiberglass and epoxy. This is an interesting project in terms of mold making because to minimize drag, the various parts had to fit precisely with one another, each nesting into a molded recess in order to be flush and streamlined. The aft end of the pylon is fastened to the wing by the tie-down eye bolt, and its cover is also nested into a joggle to fit flush. There's a gap between the pylon and the wing skin to allow room for a rubber seal, except around the leading edge where it fits tightly so it can be fastened on top with 2 screws. The simple process Mike used to produce the molds for these complex shapes is the subject of this video.
Basically, the job started when Troy and Joe brought me their ideas about what they wanted. They knew they wanted a cargo pod underneath the RV4 or RV6 wing. They knew they wanted to mount it on this hard point that is the tie-down point on the RV6. And they had several ideas about how to mount it in front, and they wanted my opinions about it. So I spent a little time making some sketches and basically trying to find out how many pieces the thing would be and how it would be mounted. And as soon as we all agreed on that, the next job was to loft it full scale. Once I had lofted it full size, then I was able to work out these dimensions accurately. This is the tie-down point here. I took the airfoil right from the RV6 plans and checked it with an actual rib from the RV6. We wanted to make sure that this fit when we were done. As soon as I had the full-size lofting, then I was able to make some templates. These templates are made from a print of this drawing that I just glued to some masonite, and once I had the templates, then I was able to start to work on the plug. I like to make plugs out of styrofoam. This is just regular construction grade styrofoam. These are 3 4-inch thick blocks that I've bandsawed out and bonded together here with microballoons and epoxy, a paste. And I've made sure that I didn't get any of the microballoons out toward the edges here where it would be difficult to sand. I like the saw because it's fast. Once it's rough cut, I put it on the bench and start working with the templates. When the tops and the sides are fairly accurate, then I work on the corners, the edges. I use various tools for this. The sanding spline you see in the foreground has 36 grit sandpaper on it, and I use a Stanley Sureform tool, sort of like a cheese cutter. And at this point I can start to use templates at various stations along the form. Now I've bonded in a 2x4 here so I can clamp it to the bench so I can work on a little more. This is a flexible sanding spline. It's made out of foam rubber and plastic. Now when I'm starting to get close to contour, I switch to a little finer grit paper. I started out with 36 grit. Now I'm using 100 grit. I have to go pretty slow here, which is the reason for the finer grit sandpaper. We're getting pretty close. It's been days of sanding up to this point, and after a final check, we're just about ready for glass. That's 2 plies of 9-ounce bidirectional on the bottom with epoxy, and we're ready to do the top. Once the glass is cured, it's just a question of a lot of body and fender work with Bondo and 2-part polyester primer. The finishing process is basically the same as the one that I used on the wheel pants in tape 3, and it winds up giving me something that looks like this. That gives me this part, but what we need now is the pylon and this cuff. Let me show you how I did that. I went back to the drawing, pulled off a couple of templates. These are 1/8" masonite, glued them to both ends of a big foam block, and hot wire cut them, and put 2 plies of glass over them, and finished them out the same way I finished out the plug. Then I put it on the bench and did a 10-ply epoxy and fiberglass layup over it. While that layup was still wet, I rubbed dry microballoons all over the layup. It soaked up the excess resin and gave me about a 32nd of an inch or so to sand on. I did all the sanding on this surface while the mold was still on the plug. After I pulled it off the plug, I inserted these 1/4" masonite ribs, bonded them into place, and these 2 spars across here. It's important on a flat surface like this to brace it up around the edges, or it'll change shape, it warps. Then I put the pod plug itself up on the bench on this styrofoam cradle and fixed it into place with these masonite braces, bondoed to a piece of duct tape that I had wrapped around the pod. And with everything leveled up, I dropped a pre-carved pylon down over the 2x4, bonded the cuff over the top of the pylon, and glassed it. 2 plies of bidirectional. After some more bondoing and primering and sanding and spot filling, we're through. Okay, so here we are. We've got this beautiful plug. It's all set up and waxed and ready to go. It's exactly the shape that we're looking for. And but wait, is it really? Let's take another look at this finished part here. This one I'm just taping together. But you'll notice that this is different in the back. It's also different up here where we need a flange up in front, and there's a little joggle here. Let's take a closer look at this and see why we can't just take a mold directly off of this that will do the job for us. The bulkhead, of course, serves the same purpose that bulkheads always do. They stiffen. In this case, we want to try to keep this round circle round. Most of the load comes up from the bottom here, up the front of the pylon. We don't want this to turn into an egg shape on us. The purpose, of course, of the joggle is to make this nose cone flush when we mount the nose cone. So the problem is how to make this joggle and this bulkhead without sawing up the plug. Let's take a look at the back here, and we'll show you the same problem we have in the back. All this area that we've cut out off the trailing edge of the pylon is necessary because, of course, we're going to mount this aluminum angle on the back here, and it carries the load up through the tie-down point on the wing up into the back of the pod. This also has a joggle so that the fairing that we put behind here, once we've bolted the thing to the wing, fits flush. So we've got another joggle and all of this stuff to fill in here, none of which is on the plug. So how do we get this shape? We've already noted that we don't want to butcher up the plug to make that cutout in here wouldn't make much sense to do. In the first place, we're going to later use this section in here to make a mold for the fairing that's going to cover up that opened area that we've been talking about. So really the only thing that we can do to put in these details is to take a mold off the plug and to put those details in the mold. So the question is, how do we make a mold? First thing we notice is that we can't make a one-piece mold. We couldn't get it off the plug. We have to make it in two pieces. In order to make it in two pieces, we have to have a division, some sort of parting line right down the middle here. And we're going to use a dam. This one is made of masonite, backed up with some scrap lumber that I've bondoed into place to make sure it stays stiff. And we're going to fit that over the plug in such a way that it will form a flange on this mold that we're going to make. Okay, I need to get some scrap lumber and rig this thing up so it'll stay in place. Okay, I've bondoed these cross pieces here and here and here to the dam itself and clamped them to these two uprights that I've bondoed to the bottom of the plug. It isn't real sturdy, but it's sturdy enough so that it's going to hold it long enough for me to clay up the edges around here. Let me show you the other side. And there we have it. I've fitted this piece up in here in front that you didn't see before. And now I'm going to take it out and clamp it to the bench. Now that it's on the bench, I get a chance to work very carefully around all of these edges. I have to fill all of these gaps around here, or the mold that we lay up here, the material will seep down through the gap and connect with the mold we're going to lay up on the back side. So these gaps have to be very carefully packed with clay, and they're done here, and we're ready to make a mold. This is an epoxy fiberglass mold we're laying up here. You notice that I haven't run the mold all the way up to the nose. We don't need that nose because we've got this bulkhead that we're going to put in up in front here. You'll notice that I've made a bead all the way around the mold. I've made that bead out of microballoons and epoxy, just a paste that I've piled up there, and the bead is to stiffen the periphery of the mold. Basically what I've done is made a thick sandwich there with microballoons in the middle. And now with the mold cured but still on the plug, I've flipped the plug over and I'm going to remove the dam here, which will leave the flange I've laid up over the dam, and I'll show you what happens next. When the dam is removed, it reveals this perfect flat flange that we laid up on the back side here. It's smooth. We've just waxed it, and we've shot the whole area with polyvinyl alcohol mold release, and we'll show you all about that later. And I've also shot it with DP40 epoxy primer, which is the first step in any epoxy mold that I make. So this mold, now that we lay up over this side, will be laid up over this flange as well as everything else, and the flange on this mold will then be a perfect mate to this flange that we've laid up on the back side. The two flanges will match exactly. After the molds have cured, they're popped off the plug, which is always a big struggle, and they're ready for trimming. Once I'd finished the pre-mold and had reinforced it on the back side, this is just 1/4 inch particle board. It's the standard stuff that I use for reinforcing molds. And the reason, of course, that I reinforced this was it's open in the front, or it was until I put this in, and I didn't want this dimension to change. I didn't want to spring in and out. So that's what all this is for. Once I had done that, then I could get to work on this stuff back in here. All of this white stuff is 1/8 inch masonite. It's the kind they use for bathrooms. It's painted on one side. Comes from the factory like that. Otherwise normal masonite. And I bonded this stuff in, as well as this little piece in here, which I took from the plug. I laid it up right on top of the plug here. It's 4 plies thick, which is the thickness of the fairing that's going to fit down in this joggle. So 4 plies is the dimension I was looking for. Took it off, split it in half, glued it back together temporarily, and then jigged it back into place and bonded it into the mold. Before I bonded these 2 pieces into place, I had to worry about something right down in here called draft. That would be right along this edge on the insert. When a mold maker attempts to provide draft in a mold, what he's doing is making sure that there are no areas, for example, if I cut that thing off straight like that, there are no areas where the mold has a return. If I laid up a part over that, the part would go down in that little return and it would hook up and I wouldn't be able to get the part out of the mold. So the way to avoid that is to make sure that any edge is cut at an angle less than vertical so that I can easily remove a part. Then I can bond it into the mold. As you can see, the 2 molds are jigged together temporarily, and there's that split down here. You can't quite see it, but believe me, it's there. It's temporarily glued together with Bondo, and this piece, which is the bulkhead to which the aluminum angle will eventually be bolted, is temporarily bonded together because it has a split here as well. It's temporarily bonded together with some popsicle sticks glued with Bondo. As soon as the 5-minute epoxy up in here cured, these little blobs that I held these in with temporarily, I packed the area up with micro balloons and epoxy, a thick paste, made a big radius all around the edges here to hold these parts in. And I also filled this area with micro balloons and epoxy. And when that was cured, popped the popsicle sticks off and pulled the 2 mold halves apart. Okay, so that's left us with this bulkhead in place and with this cap in place. And all that's necessary then for me to finish off the job is to fill in this area with another piece. You can see that I've put in the electrician's tape here that's going to form that joggle. This is standard electrician's tape. It's about 5 thousandths per ply, and I need enough for a 4-ply fiberglass layup here. That's how thick the fairing is that fits in there. So I had to use a number of plies to build it up to thick enough to accept that 4-ply fairing. So it's flush here. This is a 4-ply glass thickness. This is 4 plies, worth 4 plies of glass through here. As you can see that this area here where I packed it up with micro, it's rough. It needs a nice round fairing here. So what I'm going to do is fill that area with some clay. This is a special kind of clay used by automotive stylists and to make automotive masters with. It's called Chavant clay. It's hard as a rock until you heat it up. I heat it up in a microwave oven, which is not normal practice. It's generally heated up in an air convection oven. So I'm just going to stick this stuff right in these. You notice that I've drilled some holes in here as well so that the clay has something to grip. And I'm going to shove it right in those holes there. I'm going to build this area up with clay because working inside the mold with something like Bondo, which would be the option here, is a little difficult. I have to use hard tools to sand and shape Bondo, and it would scratch up the inside of the mold. I'd prefer to use the clay. I'm not too worried about accuracy here because I know that I'm going to get a chance to sand the mold that's going to come out of here, and I can do the final shaping then. Okay, as soon as this stuff cools off a little bit, I'll be able to do a little more shaping on it. Okay, I've filled in that area. I'm also going to use this clay to form a radius in here, all the way along here. I can tell the clay is starting to cool off because it's getting harder and harder to work. Okay, I'm going to final shape this radius with a popsicle stick. This takes a little while, but it will carve it off. This is kind of fun. I've made an aluminum template which I'm going to use to do this carving up here, because I want, of course, this edge to match the edge on the other side of the mold. So I'll use this template on the other side when I do the same work on it. And again, I don't have to be terrifically accurate here. This clay is really neat stuff for this purpose. The only problem with it is that epoxy doesn't like it very well. And polyester resin, for that matter, doesn't like it very well either. So I have to remember when I'm through with this to coat it, to paint it with shellac to seal it. Then I can wax it, and it'll be ready to use. In the meantime, I put this bulkhead up here in the front. It's made out of 1/8" masonite, just like the others, and the same kind of joggle that I did back there with electrician's tape. And the clay radius in here has been painted with shellac, and it's all ready to go. It's nice and shiny. And now we have the clay radius back in here coated with shellac, and we're ready to go. Okay, now that we've got this great thing, it's got all the details that we're looking for. It's got the joggle and the closeout in here and the flange and the bulkhead up in front, the joggle up in front. But of course we can't be taking production parts out of a mold like this. Each time we pulled a part out, it would pull out the clay and pull out the tape joggles. And besides, the joggles are rough on the edges, and we need to round them off, and we need to smooth up the clay here. It just needs some more work before it's ready to be used as a mold. So what are we going to do? Well, we're going to have to take a mold out of this. And here we are. This is a polyester mold, just the sort of mold that we would use for production. It's nice and stiff and solid. It's all one piece now. We've got all of these details back here that we worked so hard on. They're all incorporated in one piece. The only problem with it is that it's a male instead of being a female. We want it to be a female because we want the parts that we pull out to be shiny on the outside. In this case, they'd be shiny on the inside and rough on the outside. What to do? There's only one thing that we really can do, and that's we'll have to take a mold off of this. So when we take the mold off of this, let's go back and see how we make a mold, a polyester mold. First, let's talk a little about why I made these two molds out of two different materials. As I mentioned before, this mold is made out of epoxy. This is a DP40, what is actually taking the place of gel coat in here. And this mold is made out of polyester. The differences in the characters of these two materials are important in the decision whether to use epoxy or polyester. The epoxy has an advantage in that first, it's stronger, and second, it doesn't shrink. Because it's stronger, you notice it's quite a bit thinner than this mold here, which is almost 1/4 inch thick. Because it's stronger, I was able to use just 5 plies of woven fiberglass here, And also, because it doesn't shrink, I was able to lay this whole mold up all at one time. If I had tried to do this 1/4-inch thick mold all at one time out of polyester, I would have come back the next morning, it would have shrunk up and distorted. So I'll talk to you a little later about how we get around that problem with polyester shrinking so much. The other advantage of polyester is that in those areas where I need to polish, the polyester gel coat is much better, much more fun to sand and polish than the epoxy gel coat. The problem with epoxy gel coats is that by and large those that I've looked at that are on the market need to be brushed on with a brush. It's very difficult with a brush to keep the air bubbles out, so you wind up with a surface that's full of little pits and pinholes. Polyester, on the other hand, the polyester gel coat, as you'll see, we can shoot it. We can shoot it quite thick, and one of the advantages of spraying a gel coat and getting it thick is that you have enough room later in the service life of the mold to sand and polish without going through the gel coat. With the DP40, it's very difficult to build it up to 30 or 40 thousandths, which I have on this polyester mold. So for those reasons, I use epoxy for a quick, cheap, one-use mold, one-time use mold. And for anything that I'm going to either have to sand and polish, as I had to do in the back of this one, you remember, the clay area back here that I had to rework. I've done all that stuff in the mold, sanded and polished those clay radiuses up here. So anytime I have to sand and polish, or anytime I'm going to use a mold more than once, I make it out of polyester. Okay, we're going to show this mold making thing to you on a plug, not from this project obviously, but this plug, this is a medical device still under development. This plug is made of the same materials that we made the other plug with. It's styrofoam with a couple of plies of bidirectional, and it's been shot a couple of times with 2-part polyester primer and sanded out. It's sanded out to 600, and I need to make a little mold off of this anyway because I want to use it for some testing on this project. We want to make some samples, test samples. So this is the area that I want to make the mold on. The first step on any mold making is to wax the surface. We've already taken some molds off of this, so it's already waxed, but we're going to do it again as if it had never been done before. The wax I use is a Lily mold sealer 306B, and show you what it looks like. As a matter of fact, why don't we just use it right off the lid here. Interesting looking stuff.
Mike knows that a good coat of wax can mean the difference between a mold that comes off the plug easily and a mold that is permanently attached. So waxing is extremely important.
The first step is to wet out a cloth. In this case it's an old face cloth. And I'm going to scrub it in to do two things. I'm going to use this motion to both get it in all the little holes and to scrub off the old wax. This wax has solvents in it that will actually melt the previous coat of wax. So I'm cleaning as well as driving it into the holes. And I'm putting it on thick. I want to make sure I get it. Now what I'm going to do is let that dry a little bit. Okay, I've waited about 10 minutes here, and I'm going to make a couple of passes with a towel, not designed to smooth it out, just designed to distribute it evenly here. The big problem with putting on wax is that it's tough to get the swirls out when it hardens. And if you let it go long enough so it hardens, you're in big trouble. It just, unless you get a power buffer out and get some heat going on it, it'll leave those swirls, and they will of course print through on the mold. So we're going to let this dry a little longer. We'll be back. Okay, I've let it dry about 10 minutes. I'm going to very lightly, with circular motions, start to, basically what I'm doing, I'm trying not to take off too much of this wax. So what I'm trying to do is, again, spread it out very evenly. And of course, when I'm down here, it's drying up in there. The solvents flash off fairly quickly. The swirling motion is the only one that seems to accomplish this final polishing. I've tried going up and down and taking long strokes, and it never seems to work as well as this. So we are slaves to our experience. Okay, that's just about right. Now the next step is I'm going to make some dams, just like we did before. Actually, I'm just going to put one here and here, and that'll give this a chance to harden and cure. Still there are solvents in it. So that's it. Be back with the dams in a minute. This is a hot glue gun, a hot melt glue. I've discovered that it will work okay up against the surface of the plug without causing me to pull great chunks off the plug when I try to get the dam off. The dams themselves are made the same way the others were. I think this is going to stay. It's just that shiny side masonite I talked about. This is a piece of lath that I bondoed to the top of the masonite once I had fixed it, weighted the masonite flat down on the bench. And these two little tabs here are bondoed in place so that when I push it up against the plug, it fits. And now there's nothing left to do but hot glue this one down. It's important to seal up this gap between the dam and the plug, and I'm going to just do it by poking the clay in here. I have to be careful poking this clay in, because I don't want to poke it in so far that it makes the dam pop off of the plug here, which I could do. I could drive it right off here. This is a time-consuming job. I'm not going to make you sit through the whole thing, but I want to show you how it works. I've driven that in there. Now I'm going to take my trusty knife and trim it off. This knife is suitably dull so that I'm not putting a mark on the plug, and that's about all there is to it. I'm going to go all the way around now, and I'm also going to put a little radius in here. I'll invite you back when that's done. I've got the clay packed all the way in here, all the way around in the gap, and as you can see, I've already put a radius in here with the popsicle stick, just like we did before. Now I'm going to shellac. Remember, I said that the polyester resin doesn't like this Chivant clay very much, so we have to seal it, and I do that just by running a little shellac down here. And that's got it. Okay, the shellac has dried, and now it's time for PVA. This is polyvinyl alcohol. It's the classic mold release for both polyesters and epoxies. Been used for years. It forms a vinyl film over the mold, or over the plug in this case, and it releases very well. Have to filter this stuff because it will clog the gun otherwise.
Polyvinyl alcohol is sprayed on the surface of the plug just like paint. Mike starts with a light tack coat. He'll let this one flash off for 15 minutes or more, then come back over it with 2 more wet coats.
Okay, we've let this dry overnight now. It takes PVA a little while to dry. It's a water-based material, water and alcohol. And it's a very thin, very delicate film on here. Now I have to be real careful not to touch it with my hands or it'll peel it right off. It's just a very thin film. So far, everything we've done to the mold, waxing, claying, putting on the PVA, is the same process that we would use if we were making an epoxy mold. If, for example, I was going to make an epoxy mold out of this right now, my next step would be to shoot it with epoxy primer or an epoxy paint. I've seen some epoxy paints that work, but I use DP40 as I mentioned before. So I'd put on a good solid coat and let it flash off and come back a little later and put on another one. And I'd let that dry until I could touch it in some place where it didn't matter with my finger and not have any of it come off on my finger, but have it leave a very definite fingerprint. So it would be sticky, in other words, tacky. As soon as it was tacky, I'd paint it with pure epoxy, lay up a bidirectional glass cloth over it and wet it out, and lay up another one and until I had 5 9-ounce bidirectional plies on it, and walk away and leave it. After about 5 days, I could pop it off and it'd be ready to go. But we're not going to use epoxy on this. We're going to use polyester. So for polyester, the first step is polyester gel coat. This is a generic gel coat. They make it in all grades, from just regular stuff to super high quality tooling gel coat. For this purpose, we're just going to use a regular gel coat. And so, without further ado, let's get on with it.
Gel coat is made of polyester resin. It has fillers added to thicken it so it won't run when it's sprayed, and pigment added to make it easier to see bubbles when laying fiberglass over it. This particular batch is pink because it was the only color available. Looks like tummy medicine. Mike filters gel coat carefully because once catalyzed, it only has a 20-minute pot life, and a clogged gun could slow him down enough that he would have to throw the whole batch out and completely clean the gun before remixing and finishing the job. Not fun. The catalyst has been carefully measured to produce the optimum 20-minute gel time at this particular room temperature. The ratio of MEKP catalyst to polyester resin will usually be around 2%. Less catalyst is added when the temperature is high, and more is added for lower temperatures. If he puts in too much catalyst, it may suddenly harden in the gun. If he uses too little catalyst, the gel coat will remain soft forever. Because Mike has had both these situations happen to him in the past, he's very careful these days. He always times a small test sample before he starts a job like this to make sure he gets it right. gel coat, Mike starts out with a good wet coat instead of a light tack coat as he would with paint. Each subsequent coat will be applied wet, with no time allowed between coats. He'll go back over it 4 or 5 times to get the 30 to 40 thousandths of an inch thickness he's looking for. He's using 37 pounds of air pressure and a standard spray gun, equipped with an ordinary high-flow head. It doesn't work as well as a special gel coat gun would, but it gets the job done. After a half hour or more to allow the gel coat to get hard enough to lay fiberglass over, Mike draws off a cup of polyester resin. Like gel coat, polyester laminating resin comes in many formulations and grades. This particular batch is high-temperature tooling resin. Also like the gel coat, the resin is catalyzed with methyl ethyl ketone peroxide, or MEKP. Again, Mike has tested a small sample to make sure he's putting the right amount of catalyst in to get the 20-minute pot life he wants. Because the base chemicals for polyester resin are the same as the base chemicals in the gel coat, the two materials will bond chemically very well with one another. But the fumes they give off are not healthy to breathe, and Mike wears a respirator whenever he uses them. Mike is putting some of the resin aside for a moment so he can make a small amount for a special purpose. He's adding some Cabasil to the mixture to thicken it. Now he's adding some flocked cotton, or flocks, to thicken it some more and to add to the strength and impact resistance of the material. Cabasil is a common thickener for polyester resin. It's a silica substance that makes the resin jelly-like. It and flocks are available in the same places you'll find the rest of the materials used on this mold. In the yellow pages under plastics or marine supplies, and from many other mail-order suppliers. When the mixture is thick enough to stand up, it's ready for the next step. Mike is going to put it into that sharp corner where the flange meets the mold surface. He's making a little radius there with a stir stick, which will help him lay the fiberglass into that corner. Without the Cabasil and flocks radius, the stiff glass would bridge across the corner like this, and all the area in here would be air. The Cabasil and flocks mixture in here takes the place of the air and yields a solid, dense corner. He's keeping the radius small because the mixture shrinks so much when it's applied in larger amounts that it can distort the edges of the mold. This dark line is where Mike used a Cabasil and flocks radius to make that sharp inside corner bubble-free. Sharp outside corners are also a problem. The stiff fiberglass will want to go around the corner like this, leaving all the areas on either side of the corner full of air. So Mike will apply the filler here and on the other side so the glass will go smoothly over it, like this. The dark line around this outside corner is filler, which gives him a large enough radius so that the glass can go around it without leaving any air bubbles. Once the filler radius has been installed in all the sharp corners, Mike uses the pure resin he put aside earlier to paint the whole surface to prepare it for the fiberglass layup. Polyester is unique in that the fresh, uncured resin softens and penetrates the cured layer under it, forming a perfect bond between the two. This feature of polyester resin will come in handy later. The fiberglass Mike is using is 2-ounce mat, and he's tearing it instead of cutting it with scissors so that the edges will be softly tapered. Those soft edges will allow the glass he will put on the flanges to overlap this piece evenly and smoothly, without leaving bumps or lumps which would cause distortions on the finished mold surface. Now, with a fresh batch of resin, it's time to wet out the glass. Polyester resin dissolves the starch that binds the glass fibers together, allowing the originally stiff mat to conform to the compound curved surface of the plug. Mat is used here instead of woven glass because it builds thickness quickly. This single ply of 2-ounce mat will be 50/1000ths of an inch thick when wet out. It would take 3 or 4 plies of 9-ounce woven glass fabric to get it that thick. Now Mike is fitting up the glass that will form the lower flange. He's trying to shape it so it will overlap the first piece about 1.5 inches. Again, he's tearing it instead of cutting it with scissors so that the edges will be softly tapered. When he's removed the excess material on the backside, it'll be ready to go in. Because a laminate made of layers of mat has less glass in it than it would if it were made of woven glass cloth, it's much weaker than the more dense woven fabric laminate would be. But strength isn't critical in this kind of mold. What we're looking for here is thickness and low cost. Notice that Mike is leaving the edge 3/4 of an inch up above the corner. Because he's already lapped the first ply 3/4 of an inch down onto the flange, he now has the 1.5 inch overlap he wants. Those overlaps will disappear when the resin soaks in. Mat will soak up a lot of resin. The thickness of the cured mat will vary according to how much resin is in each area, and it's good to keep the thickness as uniform as possible to prevent uneven shrinking and distortion. So, Mike makes sure to give it all it will take everywhere without running or pulling up. Those tapered overlapped edges are now completely blended, so there shouldn't be any extra thick areas anywhere, which could cause distortion due to their uneven shrinking. The close attention Mike gives the job at this stage, both to the overlaps and to the amount of resin he applies, helps to ensure that the mold will keep its shape. Polyester resin has a very high shrink rate, and it's essential that extra thick areas be avoided. This nylon roller evens out the layup and works out any air bubbles that might be trapped between the glass and the gel coat. Bubbles left under this first ply will leave voids directly under the gel coat surface of the mold that can crack out or cave in later. Even though Mike wants 5 plies on this mold, he's going to stop now and allow this ply to cure overnight before going on to the next one. By laying it up 1 ply per day, he avoids the powerful forces that would be caused by 5 plies shrinking all at once, and in this way he reduces the tendency of the mold to distort. The remaining 4 plies will be done just like this one, so we'll come back here in 5 days.
Okay, here we go. We've got 5 plies on everywhere here. It's finally cured, hard as a rock. But before I just pop this thing off here, let's assume for a minute that this is just 1/2 of a 2-part mold, the same kind that we took off of the cargo pod plug, and we want the other half of the other mold half to go right up against this flange that we've made on this dam. So in order to show you what we would do to do that, let me just take off this masking around here. Although these molds are made of polyester, and those molds that we took off of the cargo pod plug were epoxy, the process is just exactly the same from here on out. There's the dam, and I'm going to see if I can't just pop that loose and stick a knife in here. Okay, it's loose all the way down. Remember, I've bondoed this together down here, so I'm going to try to get it loose up in the front here first and just pry the rest of it out. There we go. That's the dam. And here is this wonderful surface that we've laid up. You can see little bits of clay all along here, which I'm going to scoop out with the knife. That's that clay we poked in to seal that dam. A little bit of glue down here, which I can scrape right off with my fingernail. So the first step to making a mold that we would lay the flange right up against this flange on would be to get in with a little bit of water and wipe off the PVA. And as soon as I got it wiped off, I would wax this surface here. And as soon as it dried, I would shoot PVA over the whole area that I want to try to make the new mold on. And I don't have to seal this anymore. I don't have to do anything more to it. It's already, it's perfect. It's going to form the dam that this flange will be laid up on. So when I got these two flanges cured, had this one all laid up, the equal number of plies that we have on this one, before I took the two molds off the plug, I would drill a hole in various places along this flange. I can then later, when I have these molds removed, put them back together, put a bolt down through those two holes, and they'll line up perfectly. But we're not going to make that second mold this time. This time we're just going to concentrate on this one mold. So in that instance, all this flange is doing, and this one, is stiffening the perimeter of the mold. But as you can see, we don't have any stiffeners out here. So, and sometimes that's convenient to not go to all the trouble of making a dam and making a flange right on the mold. So I want to show you the reason I left these other two flanges off here is because I want to show you how you do a flange after the fact. This is just 1/4 inch particle board, and we're just going to put it up here. If I can figure out which way it goes. And I'm going to put some little Bondo blobs along here just to hold it in place temporarily, and then I'm going to come back and glass it. When we get going on that, I'll invite you back.
Before Mike puts that Bondo in, he slips stir sticks under the flange to keep it from touching the back side of the mold. Then he puts Bondo in a few places to hold everything in position. When it hardens, he removes the sticks, leaving a 1/16 inch gap between the particle board and the back side of the mold. This assures that the board won't be pulled down against the mold by the shrinking fiberglass, which would print through the mold to create an ugly bump on the front side. Even though the mold is completely cured, the polyester doesn't need to be prepared in any way before another ply is added. The new resin will soften and bond to the cured resin quite well. This is very different from epoxy, which would have to be completely sanded before another ply would bond to it.
Okay, the flange has had a chance to cure. So we have a flange all the way around. It's boxed in. We know that the edges of the mold are not going to change. They're not going to flex or distort. So the next thing is to take it off. I have no idea if it's going to come off. Isn't that fun? All right. Well, Looks good. A little hard to assess the surface here until we have scrubbed off the PVA, but it looks good. Let's go up and let's pull this off. No problem there. There's some clay. Here's the, you notice this is the clay radius up here that we put that little radius in. We'll scrape that off with a popsicle stick a little bit. And of course, once we take it outside and scrub off the PVA, we'll also scrub off what's left of the clay. That needs some sanding, obviously, and we'll get to that too. But before we do any of that, let's trim off these nasty old edges.
PVA mold release is water soluble. That's a soft dishwashing brush Mike's using. It doesn't take much effort to scrub it all off, and when it's completely rinsed there's no residue, as there often is with silicone-based mold releases. PVA has been around forever, and it's still used because it still works.
Okay, here it is all dried off. Looks pretty good. The surface is generally good. There are some little areas around the edges here where I'm not too happy with it, but we can polish those out. And also, I'm interested in what happened here at this corner where we made this clay radius. You know, this is the same kind of radius that we used on the cargo pod plug to make radiuses, as well as on the epoxy mold that we took off. And as you can see, we didn't really fare the clay directly into the dam. It's got a little ridge along here and another little ridge on the other side, and we want to sand that off. What I'm going to use to sand it off is a popsicle, this is a stir stick, paint stir stick, that I've glued some 360 grit wet or dry sandpaper to, and I'm just going to dip it in some water, and we're going to do a little sanding right on that corner. This is polyester is wonderful for this. It sands very easily. You have to be real careful that you don't go through. And I'll do this for a little while here and wipe it off. See how we're doing. Okay, we've almost got that little ridge out of there on this side. It's a little difficult to see, but it's almost gone. So we're going to do a little more sanding, and then I'm going to switch over to 600 grit, and I'll get you back when we're doing that. This is a color sanding sponge. You can get these at automotive paint supply stores, and I've glued a little 600 grit wet or dry sandpaper to it, and I'm going to get to work on this corner with it. It doesn't really take much sanding with once you've got it straightened out, as we have with the 360 grit. This is really just sanding out the 360 grit scratches. And once we've got this sanded out, I'm going to round that edge off a little bit. We are ready to do some polishing. Let's see what this looks like. It's looking pretty good. This is just machine rubbing compound. It's the stuff you can get also at automotive paint stores. This is a fairly coarse grit, and I'm just going to pour some out and go to it. I'm going to polish the whole thing before I take any parts off of it. And parts could mean either epoxy parts like we're taking off to make the cargo pod out of, or it could mean a polyester mold that we take off of this, just like we did to get the final polyester female mold on the cargo pod halves. So again, we started out with the plug, went to the green pre-molds, did all that work in there, went to the males that came out of the pre-molds, and finally to the production molds, the females, out of which we take the actual parts. Okay, finally we have this beautiful female mold, polyester, just what we need to make production parts. All the details are in, everything is ready to go. So we should have it, right? We should be able to make right and left halves with the two female molds, and that should be enough to give us all the parts we need. The only trouble is that there's more than just the right and left half of this thing. There is a necessity for us to close out the inside. We want to fill this hole up. We want to run a piece right straight across the open pylon there, and what we're going to use is this. And this came off a mold. As you can see, there are some joggles in here. We know all the problems we have making joggles, so we know this is not going to be a real simple mold either. Let's go back and see how we made this. First step in making the cuff mold was to go back to the cuff plug. And the first thing we did to it was bond this into place. It's a piece of smooth masonite bonded to this particle board, and the particle board is bondoed to the plug, and I used clay back here. I didn't want to get any bondo on the surface of the plug. Once I'd waxed up the surface of the plug, I did another layup. This time I used a sandwich of 2 plies of bidirectional and epoxy, and then made a paste of microballoons and epoxy and made it about 1/4 of an inch thick, and then laid up another 2 plies over the whole surface. So I had a sandwich with microballoons in the middle. Makes a very stiff form. I reinforced the periphery once again with 1/4 inch particle board. This time it was microed into place, and that produced this. Except it didn't produce it with these. Let me show you how we got these in here. These are the joggles. The first step was to put duct tape all over here to protect the mold surface. Then over the duct tape I laid up a 5-ply epoxy fiberglass layup, 5 plies being the depth that I was looking for in this joggle. Once again, I used dry micro over here so I had something that I could sand on. Once it was cured, I glued some 36 grit sandpaper to a round cardboard tube and sanded the surface smooth and flat. Then I popped it off the duct tape, rounded the corners, shot it with DP40, sanded it, shot it again, and cut it in half, and put the 2 pieces reversed so that their smooth ends were on the inside into the mold. They're bonded in with epoxy. Okay, as soon as we finished the work on the green cuff mold, we took this little polyester beauty out, and from it, no problem, we could get the cuff that we were looking for. It's now shiny on the inside, just like we wanted, and it will close out the bottom of the top. You know, we've had this thing upside down so long, I keep calling the top the bottom. it'll close out the pylon at the cuff. So that should be it. It's not, though. We want also, for structural reasons, to close out the inside of the pylon. That would be this area right up in here. And for that, we have another little part. Fits right up inside there. A little better than what I'm doing it right here. And I'll show you where we got that. We took the closeout right off the plug. You'll notice that I've used duct tape in here to make some joggles in the closeout. We need those joggles to fit over the joggles that we've made inside the two halves. We've also took the trailing edge of the pylon mold off the plug. Nifty little thing. And we've also used the plug to take the nose cone mold off of directly. You'll notice on the nose cone mold, which is a pretty tight bit here, this is just a piece of masonite that I've waxed up to make that collar. In order to get the parts out, and in fact to get the nose cone mold off the plug, we had to put a little air fitting in there. Little tiny hole inside, just a little black dot. I don't know whether you can see that or not. And that's it. In terms of molds, that is. There are 6 separate molds for this very simple little piece. As we've seen, this little closeout comes out of this mold. And the part goes in here, of course. Here it is, lit up like a pumpkin, bonded in up in here. The cuff comes off this mold, and it gets bonded into position up in here. The nose cone, of course, comes out of the nose cone mold. And the fairing that covers the trailing edge of the pylon comes out of this mold. And of course the right and left halves of the cargo pod itself come out of these 2 production molds. Here's a part fresh out of the mold. We haven't cut the ring bulkhead out yet. It's still got fiberglass in here. But we have trimmed this edge along here because the next step requires that we put the 2 halves together. They're temporarily held together with duct tape while I fiberglass these edges. So that I could get that fiberglass tape in here, I had to turn it up on its nose. This is the fairing where it mates with the bottom of the wing. Here's the tape down in the bottom of that groove. There's 3 plies of tape in here because we have 4 plies every place else. And we want 3 plies on the back side and another one on the front. The single ply on the outside brings the total up to 4 all the way across here. Once we'd finished all of the taping on the outside, we bonded the cuff part to the top of the pylon as well as to the back of this bulkhead. This is the area back here that we spent so much time working on, both in the polyester mold down here in the corner where we spent all that time polishing in these radiuses, as well as in the epoxy mold that preceded that. All of that work, of course, was designed to give us a recess on the finished part that would allow the fairing on the back of the pylon to fit flush both at the front and at the back. And with all the pieces in, there we have it.
Finally, to complete the job, it needs to be load tested.
Well, let's go for ultimate.
0.
0.
Okay. Going for 0.
Put the load.
The completed pod weighs 6.5 pounds, and it's designed to carry 25 pounds of baggage. It's now carrying a 27-pound side load. and a 225-pound download.
I've got ultimate.
I'm off. 0.
Okay, that's ultimate. Hang on. We should do this for 10 seconds.
Oh.
That's probably close enough, guys.
Success.
Yeah, that's all it takes to... I love it.
I like it.
And that completes the project. We hope you found this interesting and that you've been inspired to make your own ideas real. If so, we wish you great success. Thanks for watching. See you in the next video.
The AR-5 videos don't just explain the unusual performance of the airplane, but how it's made without molds, using simple tools and techniques that can be applied to race cars, boats, motorcycles, or airplanes, or anything else that needs to be light and strong and smooth. We hope you enjoy.
In an old church, armed only with a kitchen knife, a crosscut saw, and some sandpaper, Mike creates the master patterns for a state-of-the-art Formula One air racer. Starting with a pencil drawing and a small foam model, he covers the lofting of full-size cross-sections, the carving and finishing of the plug, and finally, the assembly of the airplane with its finished molded fuselage.